In section 9.2, we're also going to be interested in finding solutions to quadratic equations, but we're going to use a different method. Instead of grabbing our graphing calculators and finding the zeros on a graph, we are going to solve a quadratic equation by factoring. In class, we're going to start by discussing this example. An artist has started a mosaic tile designed on a wall. She needs to cover the entire wall. And right now, she has 4 feet by 6 feet complete, but she's missing some parts of it. So we want to write expressions to represent the length of the wall and the width of the wall. Well, it looks like the length of the wall is 6 feet this way, but then with a missing piece. And that missing piece is the same size as this, so the length of the wall would be 6 plus x. The width of the wall would be 4 feet this way with a missing piece here, which is the same length as that. So the other dimension would be 4 plus x. So what expression represents the area of the entire wall? If we want area, we would do length times width. So we'd need to multiply these two expressions together. You can either use a box to do that multiplication, or you can use distributive. If you're using distributive, it would look like 6 times 4 plus x plus x times 4 plus x. And then you would distribute, so you'd say 6 times 4 is 24, plus 6 times x is 6x, plus x times 4 is 4x, and x times x is x squared. If I combine like terms and write this in standard form, I have x squared plus 10x plus 24. Part C says, how can you determine the area of the part of the wall that the artist has not yet covered? Well, the artist has already covered this portion of the wall, and we know the area that she has covered would be length times width. So she has covered 4 times 6, which is 24 square feet. The entire wall is this expression. She has covered 24, so the amount that she has not covered would be x squared plus 10x plus 24 minus the part that she has already covered. So she has not covered x squared plus 10x. Visually, I want to show you too that if I look at this section here would have dimensions of x by 4, so this section would be 4x, and this section right here would have dimensions of 6 by x, so this would have an area of 6x, which she hasn't covered. And then this square here has dimensions that are x by x, so there's x squared. You can see that x squared plus 10x is the part that she hasn't covered. The other part of this lesson is looking at the zero product property and how we can use factored form to find the zeros. So this is factored form. Factored form is the third form of a quadratic that we know about. We've talked about vertex form. In vertex form, for a quadratic, it's easy to find the vertex. Your quadratic might look something like f of x equals x minus 3 squared plus 2. It's easy when it's in vertex form to see that the vertex is 3, 2. We also talked about standard form. if your vertex is in standard form, then your equation looks like f of x equals ax squared plus bx plus c. And the only thing that's easy to see in standard form is the y-intercept. The real benefit of factored form, so this is factored form when you have two sets of parentheses, the benefit of factored form is that it's really easy to find the x-intercepts or the zeros. The way you do that is you think about the zero product property, which says if a times b equals 0, so this is a times b, they're equal to 0, then you know the only way for that to happen is if either a is 0 or b is 0 or both of them could be 0. So I have here a product of two things. They're equal to 0, so that means either x minus 9 is equal to 0 or 5x plus 2 is equal to 0. Since they're multiplied together and they equal 0, I know that one of them would have to be 0. So I solve that by adding 9 to both sides, just like I would for any other equation, if it helps you set up your railroad tracks. So x is equal to 9 is one solution to this equation. And here I have a two-step equation, so I'd start by subtracting the 2. So 5x equals negative 2, and then divide by 5. So x equals negative 2/5. I don't know exactly what this quadratic equation looks like, but I do know that it has x-intercepts at 9 and at negative 2/5. So it would have x-intercept at 9 and negative 2/5, and something like that. I want you to take a minute and solve each of these equations. Please pause the video before you move on so that you can see how I solve them after you have tried it. Pause now and return when you've finished. Okay, here are the solutions. So this product is 0, which means I've got a times b equal to 0. So that means either a is equal to 0, so I have 2x minus 1 equals 0, or x plus 3 is equal to 0. So I'm going to do both of those two equations. This one is a two-step equation. I'm going to add 1. So 2x equals 1. So x equals 1/2 after I divide by 2. That's one solution. The other solution is if I subtract 3 here, I get x is equal to negative 3. That's my second solution. For part B, I again have a times b is equal to 0. So I can set a equal to 0 or b equal to 0 and solve each of those as two separate equations. So 2x equals negative 3. This would be 3x equals 1. Divide, so x equals negative 3/2 is one solution, and x equals 1/3 is the other solution. Okay, so you can see that if the quadratic is already factored for you, if it's in factored form, finding the zeros is just is solving a linear equation, a one-step or two-step equation to figure out what x is. If your quadratic is not already factored, if it looks like a quadratic equation, it's got a quadratic, a second degree is with an equal sign, then you have to do some manipulation before you can solve by factoring. So the first thing you want to do is write it in standard form. Make sure it's equal to 0. So I'm going to subtract 20 from both sides of this equation so that it's equal to 0, and so that the left-hand side looks like x squared plus 8x minus 20 equals 0. So the left-hand side looks like ax squared plus bx plus c. Then I need to complete a product sum table for this quadratic. So this is a review from chapter 7, but I'm going to just review it for you. So the product sum table looks like this. The product has to be a times c. So for this quadratic, a is 1 and c is negative 20. So a times c would be negative 20. the sum has to be b. So b is 8 for this quadratic. And we go through all the numbers we can think of that have a product of negative 20. So like negative 1 times 20. But those two numbers have a sum of 19, so that's not going to work. So the another option is negative 2 times 10. Those two numbers have a sum of 8, so that is what we'll use. What that means then is it means that our quadratic before we added like terms was x squared minus 2x plus 10x minus 20. That's equal to 0. So now we have our quadratic broken down into what it looked like before we added like terms. Then we're going to rewrite in factored form. And the way that I think is the easiest to do that is I think it's easiest to put these 4 terms that you have inside a box. So you have x squared, you have negative 20, and then the negative 2x and the 10x can go in either spot. Then you look at what multiplied to give me these answers. Well, x squared is x times x. 10x would be 10 times x, and negative 2x would be negative 2 times x. And then we can check, yep, that really does equal negative 20. So in factored form, I have x plus 10 and x minus 2, and that's equal to 0. The last step, we're going to use the zero product property to solve. So the zero product property says we have a times b is equal to 0, so either a is equal to 0, which means x is equal to negative 10 is one solution, or b is equal to 0, which means x equals 2 is the other solution. I'm going to leave these two for you to solve by factoring. A is already set up. It's already equal to 0. It's a standard form equal to 0. B is not set up, so you need to set it up for yourself. I'll stop the video here, and then the next, so you should pause, and then the next slide will show my worked out solutions. These are my two solutions. My product for the first problem was 8 and 8. 8 and 8 added up to, I wrote 18, but I meant 16. And it should be a 16. They add up to 16. And so then my quadratic before I added like terms was squared plus 8x plus 64. This one worked out to just have one solution because in factored form it was x plus 8 times x plus 8. So in this case, both of them are 0 if x is equal to negative 8. Just a reminder, if there's one solution to your quadratic, that means that the vertex is on the x-axis. So I know that this quadratic has a vertex at negative 8. I know it opens upward, so it looks something like that. For part B, my numbers that multiplied to make negative 64 and added to make negative 12 were 4 and negative 16. So then my solutions are x equals negative 4 and x equals 16. And so this quadratic crosses the x-axis at negative 4 and at 16, and it opens upward, so it's something like that. I'm going to leave these ones as an exercise for you, so I want you to spend some time trying problems. Remember that when A is not equal to 1, you still have to do A times C, so it's going to be a little more work.